That was your mid-semester break.
Yes.
It was a good little bit.
President Nolan and I excelled in that.
Yes. I think it's a prerequisite for being an engineer.
I think so too. It's a good thing Lucy likes things like that. So, okay, he should be good to go.
Can you see the line, guys?
Yeah.
Do I have, can you see this? The square?
Yeah.
Yeah.
Is it kind of like right at the edge of the screen though?
Yeah.
Yeah, you had the edges.
Okay, that's what I was asking. What do we got going on important date-wise, guys? Been wearing this thing all day.
All I have written down is homework number 4.
When's it due?
The 16th.
Okay. Ready to roll, guys? To me.
Yep.
So, didn't we do joint probability, guys? Last time? Yes, no? Talk to me, guys, come on. Didn't we do an example where somebody got some fruit or something like that? Was it Charles?
I do remember something like that.
So we said what, guys? You gotta help me out, seriously. So Charles has,
The question was he had 3 mangoes,
thank you.
2 bananas, and 4 papayas.
Okay. So we found, yeah, he picks 2 at random, right? Yes, no?
Yes, we had he picks 2 fruit at random. What's the probability of 1 mango and 1 banana? But I think we found that.
We found that number?
Yes.
What do we say, one mango, 1 banana? Yes, no?
Yep.
And we found that number, right? In general, it's 3 mangoes taken, this time 1 at a time. In general, it would be M at a time, right? Didn't I give you the general form?
Yeah, that was the last thing we had written. It was P of M is equal to M, B is equal to B. It's equal to 3 over M, 2 over 10, 4 over B, and 4 over 2 minus M minus B. And then all that over 36.
And in here, we would write lowercase values because this isn't a random variable quantity. It is the value of a specific value.
Yep.
It's divided by, you said 36. You got 36 by the combination of 9 things, take an 8 or 2 at a time, right?
Yep.
It's on. And here. Okay. Thing you do, go get you Sam. With something to drink for me at least. Something to drink for me at least. Okay, guys. So now what we can do, guys, do you remember when we had an open mic? Remember when we did this? We had the values of the random variable up here and the probability that the random variable equaled that specific value here, right? Remember doing that?
Yeah.
Well, this time, this marker's head. Oh, way short. This time, with the joint PDF with the screens, guys, we don't have just a unit or one-dimensional table. We have a matrix. And do you want the X value what normally would be the Y-axis? Which random variable, M or B, do you want to be here? And which do you want to be across? Talk to me. Your call. Guys, you have two choices. M or B for going down, the up and down. Hello? Can you guys hear me?
Yep.
Okay, so do you want
What about the B going down?
B going down? Thank you. What are the possible values of B, guys? That's the number of bananas in the group of 2, right? Can we have 0 bananas? Can we have 0 bananas if we pick
Yep.
2 of the 9? Can we have 1 banana?
Yes.
Either this board is not conducive to the markers I have, or they're all dying. Wonder if they're all dying. We can also have 2 bananas in the group of 2, right?
Yep.
What about now? Going across. Do we have 0 mangoes in the group of 2? Guys, come on. If you've got 9 pieces of fruit in a bag and you can't tell what you're picking when you're picking 2, can you have, of the 2 pieces of fruit, can you have 0 mangoes?
Yeah.
What if you're 2 bananas, right? Or 2 papayas?
Yep.
Or a papaya and a banana. Can you have 1? Does this go all the way up to 3? Number of, not mangoes, right? Did we decide that mangoes had an E in it? Is it ES? I think we decided that, right?
Yeah, it looks like it
That's what I
does. I just looked it up. Looks like it does have an ES, which I actually did not know.
Well, I didn't either. What's that? Was your question? Oh, hello, little brother. Hello, little brother.
He's coming to learn as well.
Yes. He could have come earlier and he would have learned a little something about resuscitation, correct?
True. He's piggybacking off of his brother's college fees to get a college level course for free.
2 for the price of 1. Okay. Guys, can we have 3 mangoes? If we pick 2 pieces of fruit, can the
No.
number, we can't. Do you see that? That's why M can only take on values of 0, 1, and 2, right? Do you buy that?
Right, because you can only have two. You can only grab 2 fruit.
Yep. So, each one of these is the probability of number of, what we say first? Number of mangoes, comma, number of bees, bananas. So this would be probability of 0, comma 0. This is probability of 1, comma 0, correct? Did I put that in the right order? Mangoes are first, bananas are, yep. So this is probability of 2, comma 0, right? And so on. Do you see how the table's going to work?
Yeah.
Everyone? You also see that this table is going to be exhaustive. It's going to list each and every possible combination, each and every possible pair of fruit. If we draw 2 pieces of fruit from among this, right? So it's going to list each and every possibility and give the probability of those pairings. Do you see that? Yes, no?
Yeah.
Okay, here we go. What's the probability that Charles reaches into the bag and does not grab any mangoes whatsoever? Nor does he grab any bananas. In other words, the 2 pieces of fruit that he grabs are papayas. Well, don't we look at this? Right? Probability of 0, comma 0 equals combination of 3 things taken 0 at a time times combination of 2 things taken 0 at a time. Very strong hint, both of these combinations are 1. Times 4 things taken how many at a time? How many papayas, guys?
2.
2. Go ahead and solve it. Tell me what you get. You get 6 out of 36. Yes, no?
Yep, that's what I got.
Now, for reasons that will become apparent very soon, if not already, it's best that we don't reduce the fractions. Okay? So just keep them over 36. Okay? What's the probability of 1, 0? 12 out of 36. Is that what you guys get?
Yep.
And what's the probability of 2 comma 0? This one's not too bad, right? Three divided by 1. 6. 3 out of 36, yes, no?
Yep.
Now we go down to the next row. Ready? Probability of 0 comma 1 now, right? In this entry, number of mangoes is 0, number of bananas is 1. So it's 0 comma 1, not 1 comma 0. Do you see the order of the variables matter? I'm gonna have to wheel the carcass closer to the ball there. Okay. So we got 3 things taken 0 at a time, right? 2 things taken 1 at a time, 4 things taken 1 at a time. Yes, no? One times 2 times 4 over 36. 8 out of 36. Is that what you guys get?
Yep.
We found the probability of 1 comma 1, didn't we? We found that the other day, didn't we?
Yeah, 1 mango, 1 banana.
Yeah. What was
I
that
think-
probability?
I think it's 6 over 36. Yeah.
Yeah. Yes. It'd be a combination 3 things taken 1 at a time, combination 2 things taken 1 at a time, times combination of 4 things taken 0 at a time. So yeah, 6 out of 36. What's the probability of 2 okay, we just did 1, 1. Now we're doing probability of 2 comma 1, right? Yes, no?
2 mango, 1 banana.
2 mangoes, 1 banana.
Yeah.
That probability is 0. Yes, no?
Because it's too many items.
You got it. Was that Charles?
No, that's Brian. I showed up late.
Brian.
Hi.
Oh, yeah. You missed my valiant attempts to revive our friend. You must have missed that, Brian.
I'll catch it in the recording.
I tried. Okay, so this is 0. Or actually, it's not even possible. You know. How about probability of 0 comma 2? What's that? It's going to be 3 things taken 0 at a time, 2 things taken 2 at a time. Well, look, guys, there's only one way to do that. Only one way to do that. And there's only one way to do this. One out of 36. Okay. What's the probability of 1 comma 2?
Also 0.
And 2 comma 2 is also. Um. Yeah. Guys, add up all these values. What do you get?
Hopefully 1.
Take the hopefully out of it. You get one right on the dot. Just add the numerators, right?
Yeah.
You add the numerators, you get 36. So you get 36 over 36, which is 1. So it doesn't prove the table's right, but it's a strong suspicion that it is, right? Oh, okay. Are there any questions on how we got the table? Yes, done?
I'm good.
Okay. Now, gonna leave the table and we'll leave this here, okay?
Wait, are these pictures of you in a lab coat from this lecture?
Yeah.
What the heck did I miss?
It was one of my finer moments. I really did a valiant effort. You guys don't mind me showing Brian what we did? Yes, no.
Go for it.
Josh and I came into room 214 at UPRC and we found this.
That's not creepy.
Very sad, Brian. He's not doing too He's not.
No.
good. We tried to revive him. We used the paddles. Well, we didn't have paddles. So instead of paddles, we kind of plugged him into the wall. That didn't,
Yeah.
that didn't. So we tried to brain dump because, the brain stays alive somewhat in the moments after your heart stops.
I've
So,
heard that before.
yeah. So we tried to brain dump, but my computer failed to recognize his brain. My career in the medical profession has been not very stellar, and I'm really upset, especially for our friend here.
But you gave it a college try.
I did, literally. Okay. Somebody remind me to get the smock back to Tony. And the gal I got this from, she runs the smock. The gal I got the smock from,
Yeah.
she runs the paramedics program and EMT program. And she used to be my neighbor, like many, many years ago. We've known each other literally for 30 years. She's a wonderful person.
Huh. Just
So,
pure coincidence.
yeah, she ended up here, and I'm like, wow, that is really cool. So I look forward to seeing her whenever I'm here. Anyway, so I go into her office. I said, Donnie, can I borrow a smock? Like a nurse's or a doctor's smock. And I at first I totally expected her to say, why do you need a smock? But Donnie, she looked at me, she goes, yeah, well, I think I can drum one up for you. She didn't question it at all. And later on she said, well, I knew it was you, so I knew you were going to do something with it.
Yeah.
Yeah.
That's cool.
All right. I thought that. Thank you. Wanted to have fun with it. Here's a question for you guys. Oh, here. Let me ask. Oh, Corey. What is your of the three types of fruit here? What's your what's your favorite?
Who are we asking?
Well, we originally asked Charles, but that's good.
Personally, I love mangoes.
Mangoes. Okay. So, sorry, Charles, a little too slow on the draw there. So, what's the probability that m equals 1? We know the probability of m equaling 2, right? Right, guys? It's 3 out of 36,
Hmm.
right? What's the probability that m equals 1?
Can we just add the other two probabilities?
Do you see that we can add them? Just as Brian said. There's a rule that says we can do this, right?
Yeah, it's like the summation rule or something, additive rule.
Sure. Axiom 3, right? Because this event is mutually exclusive from this event, right? If you draw one mango and one banana, that's totally different than one mango and one banana, right? You can never do both at the same time, right? So we can just add them because they're mutually exclusive. Does everyone see that?
Yes.
No? So what do you get? I get 18 out of 36. Right?
Yeah.
Just add these two numbers, guys. Does anyone not see that? Are we good? I will take that as a yes. Well, we know what the probability of 2 mangoes is. We know what the probability of 1 mango is. Here, I'll just denote this summation m, okay? So this is probability m equals 2, and this equals 3 out of 36. M equals 1, 18 out of 36. What's the probability that m equals 0? Well, I'm going to tell you right now, without even looking at the table, it's 15 out of 36. How can I do that? Yeah.
Because you can subtract the other two from one, and that should give you the leftover probability.
All of these values, they have to equal 1 as well. Do you see that?
Yes.
Does anyone not see that? Are we good? Talk to me. Everyone's quiet today. You're all quiet, Josh. What? You're all quiet. Oh. Rhythm. I don't get to eat my burrito until we finish class. So let's try and make it quick time. Which means everybody talks. So guys, these are called the marginal probabilities. Do you see why they're called marginal?
I was just about to ask what it meant.
What marginal meant?
Yeah.
Where did I write those values? Did I write them inside the table?
No.
I wrote them on the margin of the table. Right?
Yeah.
Can you picture putting this table in a notebook? Right? So you got the area of the table, and then you're like, oh, you know what? It'd be nice to know what the probability of, this variable up here, x, y, m, p, b, whatever. It'd be nice to know what the probability of that guy being 1 is. Well, where are you going to write that probability? You're not going to write it inside the table because those are all joint probabilities. Where are you going to write it? Well, the easiest and most logical place to write it is below the table. What was the area below the table called? Well, other than the rest of the page, right? You might call it the margin of the table. If you can't picture that, we're gonna find give me the marginal probabilities of B. What's the probability B equals 2?
1 out of 36.
What's the probability B equals 1?
14 out of 36.
And I don't have to look at it, this is gonna be 21, right?
Yeah.
Well, if this table occupied the entire width, writable width of the page, these would be in the margin, wouldn't they?
Mm-hmm. Like the side margin.
Right. You see that?
Yeah.
Okay. Are there any questions?
Are there like other types of marginal probabilities, or is it just like the totals, the sums?
It's the totals problem.
Okay. Okay,
So-
that makes more sense.
Yeah. Is this stuff over here?
Yeah.
Yes, down, going once, twice. Okay, guys. Now, in general, so given a joint probability density function, discrete. Okay, I can do it this way. The joint probability density function with random variables x and y. The marginal joint probability. Oh shoot! You know what? I could just say it this way. My bad. Lowercase f of x comma y. So that tells you what the random variables are. Okay. So x and y go together or are part of a joint probability density function. Could be continuous, could be discrete, does not matter. I'm trying to make this as general as possible so you don't have to memorize a whole bunch of different things. Just take a look at one thing and figure out how to make it discrete. The marginal PDF and by the way, guys, do you see that this right here, this is a probability density function of just B?
Yeah.
You see that. it meets all the rules of probability. This is a probability density function in and of itself of n. Okay? So the marginal PDF of x, and it depends on the book, okay? Book depends on who you talk to. Let's just call it g of x equals summation f of x comma y over all y for the discrete case. It equals the summation of f of x comma y, I'm sorry, not the summation, the integral, dy over all y. Okay. In the discrete case for g of x, what you're doing is you're adding all of f of x values over y. Okay. Keeping x constant. Here, we're integrating out the variable that we don't want. So these two, I hope you see the similarities between the two forms. I really hope you do. Right?
Yeah.
What do you think h of y is? H of y is the marginal of y. What do you think it is? Whatever, right? Whatever.
So it'd be the summation over all x of fx xy. And then,
For the discrete case, right, guys?
right. And then continuous would be the integral over all x fxy dx.
Does that make sense, guys?
Makes sense to me.
Does it not make sense to anyone at all? Are we good? Okay,
I think so.
and everybody's good? Yes, no? Ready to do a continuous example?
Yes, please.
Can I reboot the board?
Unless you want to keep that. Oh, never mind. No, that can go.
Okay. Board content going once, going twice. All right. Okay. What kind of function do you want? Do you want something complex? Do you want something exponential? Do you want something fairly simple?
Let's do.
How about if we do something relatively simple to start?
Okay.
And I don't know if you've noticed this. This is one of the reasons why I kind of was thinking maybe lecturing from school would not be a good idea. I don't have my notes. They're at home. I was supposed to leave work at 3:00, which means I would be home by maybe 3:30, not 3:30. At the latest 3:45. And, if I got stuck by a train, probably 3:50, but more than enough time to get set up. I didn't get out of work till 3:20. Okay. So in order not to lose, at least 10 minutes, probably more like 15 to 20. I say, well, with this lecture, you're see, but I don't have this. But we can still come up with some. So are you ready?
Yeah.
Oh, here's not a famous one, but, where am I picked on? Liam, is it your turn to be in the pickle barrel?
It might be.
Today it is. All right.
Okay.
What kind of jobs have you had? Just make something up if you want. I don't care.
What was that? You kind of cut out there.
What kind of jobs have you had in the past in your past
Oh.
life?
I could just do jobs that I previously had. I was a ride operator.
Really?
Yeah, at Cedar Point. Yeah. A fuel pier attendant and a Starbucks barista.
Okay, we're probably gonna pick on the Starbucks barista, I guess, because that kind of lends itself well to the example I want to do.
Okay.
So you were a Cedar Point ride operator, so like were you one of the guys that, did we lose something?
No, you're good.
Okay. Were you one of the guys that said, yes, everybody's buckled in?
Yeah, one of those guys.
So you weren't the button presser?
No, I actually did get trained to be the button presser as well.
Okay.
Yeah, I worked on the Top Thrill Dragster for 2 years. That was my main
Wow.
ride.
They
Yeah.
took that out, didn't they?
No, it's still there, but it's going to be heavily inspected after the last incident.
What happened?
A piece of one of the trains, I think like hit like came loose and hit part of the track on its way down, and then it dislodged from the train and hit a woman in the head who was waiting in line,
Ooh.
God.
and she's in critical condition. And the weird part is that in my second year there, which was my last year working at Cedar Point, because then I started doing internships in the summer instead. The same thing happened, but the person wasn't nearly as badly injured, and they just were cleared at the first aid station at Cedar Point, and no one ever heard about it.
That is very crazy.
Yeah,
I assume that person started going to church if they didn't before.
yeah, it was. They were lucky for
Very,
sure.
very, right?
Yeah, I think that the time it happened while I was there, it did a lot more damage to the ride than it did to the person that it hit, because like all the brake fins on one side, those like brake fins that stick up out of the track. I don't know if they replaced them now, but that year, if you had gone there and looked, there was like a corner cut out of each one because it bent the corner back on each one of those brake fins as it came down the track, and so the maintenance just took off the brake fin, like cut off the portion that was bent, flipped it around, and put it back in again.
Wow.
I feel
Yeah.
like that is not up to code.
Did any,
I mean, you would think that, but the way that because they're not friction brakes, they're eddy current magnetic brakes. So as long as there's a good majority of the material still there, and there's lots of them, then it will be fine.
yeah, and if you do the analysis, were they rectangular shaped?
Yeah, they were rectangular shaped.
All right. The eddy currents, I'm familiar with that type of braking. The eddy
Yeah.
currents in the corners of the rectangle were pretty low.
Yeah, so it was like because that's like the only way you can slow down really fast moving roller coasters like that, because friction brakes would just get worn out super fast.
They were-
So
they
that's yeah, so it ended up being fine. But yeah, any other ride they definitely would have had to change all the brakes.
Yeah, yeah, yeah. Back in the day, you guys are most of you are probably too young. They used to do emissions checking by you'd have to drive your car at the emission station, right? But the drive wheels, if it was front wheel drive, the front wheels. If it was a rear wheel drive car like most trucks, it'd be the rear wheels. They would be put on couple of rollers.
Yeah.
So here's the floor. Right? So here's the truck tire, say, or the car, whatever. Right? So it'd be spinning this way, right, as it's trying to drive. But instead of moving forward, the wheel just rotated these two rollers. Well, these two rollers were they were on an eddy current system, and something called an eddy current brake. And when you run out of things to do over break, look this up because it's pretty fascinating. And if you like physics, especially electromagnetism, the process of eddy currents is actually kind of fascinating. It's a very efficient, somewhat low cost in terms of horsepower that it can support. Way of stopping something.
I assume it'd probably be like kind of low maintenance too, because you're not really actually contacting anything.
Exactly. That's where I was gonna say, as Liam mentioned, there's no maintenance because there's no friction except for in the bearings. So, but that's how they used to do emissions testing. They put the car here so it didn't have to actually move, to simulate loading. And
I would like to drive for a little bit.
we have a class crash thing.
Brian, is there someone in your background?
Yeah, that's Kirsten just came in.
Hi, Kirsten.
Hi.
Did Brian mention that?
Hold on. Give me 1 second. You're on not on the speakers.
Okay. Did Brian mention that you made the midterm opportunity?
Okay. One more time.
Did Brian mention that you made the midterm opportunity?
Yeah, I saw a picture of that.
Yeah, I was disappointed that he didn't mention it. That's okay. I'm used to disappointment.
You were right about the car problems too.
Was that the one where you had a bunch of car problems?
Yeah, it was like there's like the windshield and I don't remember what else.
Overheating and a flat tire, right?
Yeah, overheating, flat tire were the other two.
Yeah. Were my probabilities correct? Well, I guess it does. But anyway.
You're like cutting out.
Sorry?
You were cutting out.
Oh, I bet you it's because I'm turning away from the mic. I'm sorry. Back to our eddy current thing, right? So the operator of the eddy current brake could like simulate the car going up a hill by increasing the braking of the two, of these two rollers, right? That would simulate like a load being put on the car. And for the emissions, they just put a pipe, a tester in the exhaust pipe of the car. That's really the bottom line for emissions, right? What comes out of tailpipe. So anyway, that's your EMAG lesson of the day. Anyway, let's see where were we? Oh, we. Liam's, is that what they call them, baristas?
Yeah, I guess so. I don't know. I just work at a local Target, and like I work in the front, and so one of the things they have me do is Starbucks because it's part of the front.
So, for Dean's barista job, requires him to make, what's one of the drinks, one of the coffees? Like they're all different fancy coffees, right?
Yeah, we could do the caramel ribbon crunch frappuccino. Yeah, I know, right? It's the caramel ribbon crunch frappuccino. I'm just trying to try to pick like the most ridiculous ones that we make.
Ribbon?
Yeah, caramel ribbon crunch frappuccino.
I'm not gonna ask you how it functions.
Would you rather have me?
Cappuccino?
You like
A frappuccino.
Oh my god.
one
I honestly don't even remember how to spell frappuccino. I'm not gonna lie.
Anyone know?
Make up your mind.
I think it's got like 2 P's. I don't know. I could probably look it up.
3, 2, 1.
Yeah, it's FRAPPUCCINO.
That's exactly what I was thinking. If I tried to type how I thought frappuccino was spelled, Word would have just said, huh?
Yeah.
Okay.
Not into it. And
Okay. I'm gonna ask the
they didn't all
question that at least some of you are probably asking yourselves,
Yeah,
what's a frappuccino?
just looks my mom.
I don't actually know the exact definition, but I think it's like an iced cappuccino, basically, and like blended and stuff.
So how come they don't call it an iced cappuccino?
Are you sure?
Because I don't know, they just came up with a catchier name.
Answer. Are you sure? Yes.
It's just how Starbucks makes their money.
Okay.
I was never a huge coffee person, so I never bought from Starbucks, so I don't know much about like the coffee stuff.
Well, we're asking these questions of the wrong people, like my wife and probably my daughter actually. So what's a cappuccino? What's the difference between a cappuccino and a coffee?
I can look it up. A cappuccino is an espresso-based coffee drink that originated in Austria. So it's based on espresso, I guess.
So what's the difference between espresso and coffee? These are questions that I lie awake at night wondering. You know,
Let's see.
has anyone ever thought that maybe the world's a bit too complicated? Is the espresso the really highly caffeinated one?
I think it's more concentrated.
Oh. And it's ES espresso, not EX as in
Right.
X.
It's ESPRESSO.
Okay. I still don't understand anything. So it's got caramel in it.
Yeah.
What else does it have in it?
It's got like
It's obviously got espresso
Yeah.
coffee stuff.
I think it's got like some like crunchy like cookie stuff in it too, like chocolate like cookie bits or something.
I assume it's ungodly expensive.
What was that?
I assume it's ungodly expensive.
Yeah, I think it's like just under or around $6 maybe
What,
for like a big one.
8 big ones? So that's like,
I think a big one's like 22,
oh, that's
or maybe that's like the biggest one I remember. I honestly like after I started working there, I was surprised. I thought stuff was going to be way more expensive than it was. It's still kind of expensive, but I thought it was going to be a little more expensive than that.
I mean, the horror stories about Starbucks prices.
Yeah, I'll see people get like two like good sized drinks, and it'll be like around like $10, which I honestly didn't think was too terrible considering the price of other things right now.
Agreed. I mean, yeah. There's a lot of things in life I don't understand, guys. So, so this thing has caramel. Help me out. Caramel.
Normal. Uh,
Cookie.
Is that like
no,
cookie
chocolate,
bits?
chocolate, something or other.
It's like chocolate cookie bits. Like it's like yeah, not like a chocolate chip cookie, but like if the entire cookie was chocolate flavored and then like bits of that cookie, that's what it would be like.
Okay. Okay. And it's got espresso.
And whipped cream.
We're gonna ignore the whipped cream.
Okay.
And you ran out of whipped cream.
Right.
So, let's do this by mass, by weight. And we're gonna ignore the water. These, okay, I'm trying to set up the problem. Fraction. Normal is what? Give me random variable.
What was that? You kind of cut out.
Sorry, I keep turning what do you want to call the fraction of, well, so let's talk. So Liam's, going about his, what store you work at?
Target.
Target. So, Liam's going about his Target. Oh, I see why they have Starbucks at Target. I bet you caffeinated shoppers buy more.
Yeah, and Target just has like a reputation for being like a rich person's grocery store nowadays.
That I didn't know. Interesting. So, guys, does everyone see? We are about 15 minutes, right?
Yeah.
Does everyone see that, Liam's, going about his business, going back and, putting on his fancy hat? I assume you have a fancy hat. When you're
Yeah.
serving overpriced coffee to, customers.
Yes, they provide us with a little visor that is way too small for my head.
Okay. So, but do you see, ladies and gentlemen, I assume there's ladies still, that, I don't know who else is scratch classy. Each caramel ribbon, I can't even say it. Caramel ribbon crunch frappuccino, which is like a cup of coffee on steroids. Is that a valid description?
Yeah.
I mean, it's not an insult, really.
No, yeah, I mean it's just got a lot of stuff going on in it to try and counteract the flavor of coffee.
Yeah, which is pretty nasty.
Yeah. Oh, well, if that's the case, they also sell cream frappuccinos, which are literally all the exact same things, but just with a cream base instead of a coffee base.
Really?
Yeah.
So, but time out. If you're just eating chocolate, caramel, and cream, like, where's the pick me up, right?
I don't. There isn't really any. I guess maybe from like sugar, but
Yeah.
I mean, it's for people. I guess it's for like people who are drinking it because they want it to taste good instead of drinking it because they need to stay awake. Also, like later in the day, you could probably buy that instead. Because the Starbucks stays open until 9 o'clock, which I thought was really strange that they stay open that late.
Yeah. I bet you they get a fair amount of business after dinner. So anyway, Liam's making his caramel ribbon crunch frappuccinos, among other. Do you see that each one's gonna be a little different than the one before? I mean, Liam, I assume when you're making one of these things, you know, for, you know, Joe customer, that you don't weigh, even if you did, but you don't weigh the amount of caramel that Joe customer is gonna get. You don't weigh that to the nearest microgram, right?
No, we just kind of use like a little nozzle thing and just kind of spray it on there.
Just,
Yeah.
okay, that looks good, right?
Yep.
So, even if you did weigh it, my statement here would still be true. Each one's different than the one you just made,
Right.
okay? And even if you measured everything, the statement's still true. You know, you meant to put in, you know, 39.389 grams. Well, did you really put in that? No. Might have tried, it might be close, but no, you didn't. So, do you see, knowing that, do you see that the amount by weight or by mass, these three ingredients make up the whatever it's called, and each one is a random variable. Do you see that?
Yeah.
So, what do you want to call a fraction of caramel? Guys, come on, pick something.
C.
Okay. C can range from 0, less than or equal to C, less than or equal to 1, right? Correct?
Between 0
Yep.
and 1.
Yeah,
Just-
it's a fraction. It's a fraction.
So no caramel to the entire cup being caramel.
Yep,
Okay.
yep. What do you want to call the amount of chocolate by mass, right? By weight, the amount of chocolate cookie bits.
I'll have to do B.
B, okay.
Yeah, because C is already taken, so we'd have to do like CC or something like that. But I think B works.
You see, that's going to go from the range of that's going to be 0 to 1. What about espresso? Remember, we only have 3 ingredients here.
We could keep it simple and go with E.
Well, is it really a random variable though?
No,
Yeah.
because based off of the other two, you already know how much espresso there is.
Oh yeah, true.
So C plus B plus the espresso, right? So the amount of espresso is really not a random variable because if you know C, the value of C, and you know the value of B, you know the value of espresso because they all got to add up to 1. Does everyone see that?
Yeah.
Okay, so so the amount of espresso, I'm just going to write it down. It's not a random variable, guys. The fraction of espresso equals 1 minus C minus B. So we can say that f of the probability density function of f of C comma, do you want to go B comma C or C comma B? How about if we go alphabetical order?
Yeah.
Equals something that I'm going to give you or we can define. It's up to you. The conditions, guys, and I'm gonna be a little bit more of a stickler than we have been. It's 0, so that's very equal to C, less than or equal to 1. B is also between 0 and 1. There's one more. C, 0 is less than or equal to C plus B, less than or equal to 1. And no, we can, here, this is better. No, that's right. 0 less than or equal to C plus B less than or equal to 1. Okay? Now, let's talk about the actual probability. Oh, and it's, okay. Let's talk about the probability density function. Let's go some constant A times, let's make it simple. Okay. It's equal to A times 2C plus 3B. And I can change them if you want. I can change any of the coefficients. A is a constant that we don't know the value of. Okay? All right? Does everybody have that?
Yeah.
I can change these constants if you want, just tell me. Okay? Now, f of b comma c equals 0 elsewhere. Okay? Your textbook, even when there's only one random variable in a function, your textbook for both discrete and continuous, when your textbook gives them completely correctly, they do something like this, okay? Where they give you the density function, okay, or distribution function for discrete. They give you the limits, okay? You know, the boundary conditions, right? Those kinds of, but the boundaries for the random variables and any other constraints. Now, but they also say that the value of the probability density function is 0 if these conditions are not met. And that is the most complete and concise way of describing the entire probability density function. Okay? Are there any questions so far?
No.
Can you see the green?
No, not really.
Is this marker dead? Oh, yeah. Quite right. You can see that, right?
That's better.
Kinda.
Can't do much of anything until we find the value of A, right? Is this visible or should I change to a different marker?
I'm okay with that.
Can everybody else see it?
I can see it.
How's the purple? That shows up pretty good, right?
Yeah.
And we're gonna have to find mean values of X and Y. Okay. Number C, find sigma X, sigma Y. And D, this is gonna be some new stuff for us. Find, First, we're gonna find, give me some numbers, guys. Probability that B, give me some bounds for B.
0.5 and 0.73.
Give me some bounds for C.
0.38 and 6.
And then give me some bounds for probability. Yeah, let's do this. Out here. Oh, yeah. 0.5 is less than or equal to B, less than or equal to 0. Yeah, let's do this. And these up here are marginals, guys. Okay, this probability statement of itself only involves B. This one only involves C. This one, the bottom one here, involves B and C. Okay. And then E. Find sigma x, y, and rho x, y. This is a rho, not a p. We don't know how to do this yet, but we will on Thursday. Okay, guys? Any questions?
What'd you write for E? You're blocking it.
I'm sorry. We need sigma x, y. You don't know how to do that yet. That's called the covariance.
Okay.
And find rho x, y. Rho x, y is real simple if you know sigma. But again, we don't know how to do that stuff yet. Well,
Okay. Thank you.
right? We'll pick it up here on Thursday, and I'll be home on Thursday. All right? Are there any questions?
None from me.
Everybody good? Okay, we'll pick it up here on Thursday, guys. Have a great Tuesday.
Thank you.